Now we will learn some general consideration regarding sample line design. First we will talk about line length and diameter. It is always best to keep sample lines as short as possible, to minimize transport log time. Also, use the smallest diameter line available to ensure a representative single-phase sample that is consistent with the required flow rate and the available pressure drop. Sample supply and return lines of a 1/4 inch outer diameter, with a 0.035 inches wall thickness are common for many analyzer systems. Next, we will talk about tubing runs and sample pressure. Tubing runs of seamless tubes are recommended because of many reasons, such as its metallurgical properties, the smaller internal volume, less entrainment due to abrupt bends, and finally ease of installation. Another important consideration is that we have to provide sufficient pressure to maintain adequate velocities. Typical linear flow velocities are from 2 to 4 meters per second for liquids and 7 to 15 meters per second for gases. Another point we are going to discuss is the size of the fast loop system return line. We have two cases. The first case where we have enough differential pressure between the sample point and the return point. In this case, make the fast loop return line the same size as the supply line to simplify construction and keeps the pressure gradient the same in both lines. The second case where we don't have differential pressure between the sample point and the return point to drive the sample in both lines. In this case, increase the diameter of the return line. Process fluid will slow down in the larger bore sample return line and therefore, need less driving force and free up most of the available pressure for driving the supply line.